Guys, our next video, derivation of the time period of the moon. At first we have to know about the what is time period. Time period of the moon or time period of the satellite. As we know, the satellite means the moon, which is the satellite of the earth. Now the time taken by the satellite to complete the one revolution or the rotation around the earth, that is known as time period of the moon. Here this is the mass of this is the mass, or this is the satellite here, and this is the earth. Time period means the time taken by this satellite to revolve around the earth, that is known as the time period of the satellite. Here the derivation is now time period. Time period T is equal to circumference of orbit fraction orbital velocity. Circumference of orbit. This here circumference means 2 pi r. This is the radius from this point to this point, this mass. The r is given by r plus h, which you take this, and orbital velocity 2 pi r means r plus h here, and the orbital velocity gm divided by r plus h. Okay, and this can be written as r, this multiply this r square into r plus h root under divided by gm, then 2 pi is equal to r plus h whole cube divided by gm. This one, these are one equation, and as you know, g is equal to gm by r square. Acceleration due to gravity is equal to gm by r square. Then we can also write gr squared is equal to gm. By this, here we can write 2 pi under root r plus h whole cube divided by gr square. Okay, and therefore our time period is r plus h whole cube divided by gr square. Now in terms of density and radius, in terms of density, radius and gravitation, okay, in terms of density rho, we are finding the time period. Therefore mass m is equal to v into rho. V, we always considered the radius, we always consider the shape of the earth is sphere, so we can write 4 by 3 pi r cube, and rho this 4 by 3 pi r cube. Therefore from equation I, from this equation, t is equal to 2 pi root r plus cube, r plus ch को whole cube divided by gm 2 pi under root r plus h को whole cube divided by g. Mass, we have find this relation, mass 4 by 3 pi r cube rho, and this can also be written as 2 pi root 3 pi r plus h whole cube divided by g into 4 pi r cube rho. Then after time period is equal to root 3 pi r plus h whole cube divided by rho g r cube. The here 2 pi and 4 is cancelled out when they go outside. This is our equation second in terms of the density. Now for the time period for the for closed satellite, what is the time period? Okay, that is when the radius is too much larger than the height of the satellite from the earth's surface. Okay, at that condition r plus h goes very close and it becomes this. Now we have find 2 pi root r plus h whole cube, which is the time period of the satellite, gr square 2 pi root under by the above relation here r cube divided by gr square and then 2 pi root r by g. This is our new relation of the time period of the satellite, and this one in terms of the capital G we can also write it as 3 pi upon rho g. This is our the relation. By the above all the question we are concluded that the time period of the satellite, the formula can be also written as r plus h whole cube divided by gm or 2 pi root r plus h whole cube. Gm is equal to gr square. This and the another formula of the time period is 2 pi root 3 pi plus s. This is in terms of the density rho g r cube, and these are the for the normal satellite, and for the very close satellite where the height is very less, so the time period for that satellite is r by g, or time period can also be written as 3 pi rho g for the closed satellite. This is our uh, formula, or this is our derivation of the satellite. Okay, thank you.